Welcome back to this S2 video, and this one's on modelling with a Poisson distribution. Now, in terms of the modelling, we need to be able to recognise when we can model things with a Poisson distribution. And we've already kind of talked about this in previous videos, where we are looking for events that occur independently, singly in time and space, and at a constant rate. Now, in particular, that word rate is really important, because if you can find that within a question, that's what's going to indicate that you're going to need to use your Poisson distribution. So things like, when you have a 5-minute or a 10-minute period or a 30-minute period or a 5-hour period, those kind of things you get a rate from. Another thing could be the number of spelling mistakes on a page, the number of cars passing within a interval of a specific time, like a 10-minute interval. All of these things will indicate that you're going to need to use a Poisson distribution. One of the hardest things in S2, and certainly in terms of the exam, is deciding whether a question needs you to do Poisson or binomial. Okay? And looking for these kind of keywords is what's going to help you. Now, this is something I'll bring up when the questions arise as we go through these videos, and towards the end where we start combining both Poisson and binomial within our questions. So we will talk about this quite a bit, but for now, let's get stuck into the first example. So here we have the number of patients visiting a clinic that treats insect bites can be modelled as a Poisson. So we don't need to guess here, it's just a straightforward one, but that won't always be given to you. In fact, it's quite rare. Now, these are the kind of words that we're looking for: rate. When we see that, rate of 3 patients per day, that's what really indicates that it's Poisson. So if we weren't given this information, this is where we're going to go to determine whether it's going to be a Poisson or a binomial. So let's look at our actual distribution. So we're going to use X, Poisson, and our value of lambda is 3 patients per day. And for part A, what we want to find is the probability that there are more than 4 patients on a given day. So more than 4 is going to be greater than 4. And remember, we always want this with an equals within our inequality, so greater than or equal to 5. That's what we're trying to find. Now, since this value of lambda, here, 3, since that is in my tables, what I will do is use my tables instead of any formulae. So here we're going to go 1 minus the probability that x is less than or equal to 4, because obviously greater than or equal to 5 is the same as 1 take away less than or equal to 4, and my tables are always less than or equal to. Now here you can see that 4 is 0.8153. So we've got 1 minus 0.8153. And that gives me 0.1847. Now for part B, we've got an extra doctor is required at the clinic if within a 5-day period, at least 4 of the days have more than 4 patients. So you'll notice that this sentence here, at least 4 of the days have more than 4 patients, is what we did in part A. Okay? But now we're extending that over a 5-day period. Because we're extending that over a 5-day period, this bit now is going to indicate that it's going to change into binomial. And this is a very common theme within the exam, where you might start with a Poisson distribution here, and then one of the later parts then will switch to a binomial. And in this case, you'll be using the probability that you worked out with Poisson. So our new distribution is binomial. We're going to change the letter to y now. B for binomial, and it's NP. So N is now 5 for 5 days, but probability is 0.1847, which is the probability that we worked out in this part A. Now what we've got to do is, an extra doctor is required if within a 5-day period at least 4 of the days. So this means now that we are looking at Y is greater than 4. Because earlier it was more than 4 patients on a given day, and now we're looking at 4 days where there are more than 4 patients. Which means that we're looking at the probability that Y is greater than or equal to 4. Now, quite clearly, this probability is not going to be within my binomial table. But luckily, if I look at this, it's only a 5-day period. So greater than or equal to 4, that's going to be the probability when Y equals 4, or the probability when Y equals 5, isn't it? Just the 2 days. So what I can do now is use binomial to work this out. So thinking of my NCR, that's going to be 5 and 4, isn't it? And then we've got our probability, so 0.1847 per 4. And then we've got 1 minus that, 0.1847, which we already know, don't we? As that is something that we used in the previous question. So I can just pop that straight in, which is 0.8153. And then we went for Y equals 5. So that's 5, 5. We don't really need to put it down, as it is going to just be 1, isn't it? But I'm just going to pop it all in here to the power 5, 0.8153 to the power 0. Once I'm done with that, we should get 0.00496 there to 3 significant figures. Hopefully that wasn't too difficult and you were able to follow it. Let's have a look at a second example. So in this question, we have an estate agent selling houses at a rate of 1.8 per week. So we can see that word rate in there, really important there. Show us that it is going to be Poisson. Okay, so obviously we've got our fixed time and so on there. So value of lambda is going to be this 1.8 here. So for part A, we need to find the probability in a particular week that she sells no houses, 3 houses, at least 3 houses. So part A, we're looking at Poisson distribution with 1.8 as our value of lambda. Part 1 is no houses, so probability when x equals 0. So for this, we just use the formula. So we've got e to the minus 1.8 times 1.8 to the power 0 over 0 factorial. That is going to give us 0.1653 to 4 decimal places. Now, part 2 is 3 houses. So probability when x equals 3. So pretty much the same thing, e to the minus 1.8 times 1.8 to the power 3 over 3 factorial. And that gives me 0.1607. And again, this is to 4 decimal places. And then the final part, which is part 3. This time we've got at least 3 houses, so it's going to be greater than or equal to 3. Now that means we were looking at 1 minus the probability that x is less than or equal to 2. And this kind of poses our first problem. 1.8 is not a value in our tables as they go up in 0.5s. and our only option is either to use the formula or to use our Casio calculator. So at the moment I'm going to assume that perhaps you don't have one, so let's do it with the formula. But with the formula, what we're basically looking at taking away is when the probability of x equals 0, the probability of x equals 1, and the probability of x equals 2, which I'll just squeeze in there. You can have it like this with the brackets and add those up first and then take them away, or of course you could remove these brackets, couldn't you? And you could just turn these plus signs into minus. So, we would be taking away this one, taking away this one, taking away this one. It's totally up to you how you prefer to do it. Now, we've already worked out 3 and we've worked out 0, so we've got 0 and you know how to work these out. So I'll just pop the answer up here. So the final answer for this one will be 0.2694, again to 4 decimal places. Obviously, it's when you have this type of question here is when those Casio calculators become really useful, because this will save you doing these 3 calculations and then taking the answer away from 1. All you need to do is actually, I would probably take an extra line here. So if I did this in my calculator, I would get the value of this x is less than or equal to 2, which is 0.73062. Does kind of keep on going there? But I would get that first, okay, and I would make sure I've written 1 minus it down, because that then is these 3 values added up, and that saves you a lot of hassle, okay, and that is enough working to be able to get the full marks on this one. So rather than just put this straight into your calculator, by writing some of this out will just make your life a little bit easier and just ensure you get the full marks. Now, as there's nothing new in this one really, it's just moving into the more worded questions. What we'll do is we'll just look at 4 quick questions for you guys. Don't forget to pause them, have a go at them, and as always, the answers or the solutions will be at the end of the video. Enjoy. So this question here, we can see the word rate in it, which is what's gonna, tell us that this is a Poisson distribution. That's the biggest hint for you guys. Obviously this one's been a bit simpler with this extra sentence in here, which, equally we could have not even had if I got rid of it. It would still be something that, you should be able to solve without that sentence. Because you've got this word rate, spotting that rate means you're going to be looking at a Poisson distribution. Certainly for, in S2, because it's only binomial Poisson and, of course, normal from S1, which does show up in S2 as well. Now, for part A here, we can see that in a randomly chosen week, the number of requests is exactly 4 and more than 5. So we are looking at Poisson for 3, and for part 1 we're looking at when x equals 4. So for this, it's obviously going to use the formula. So we get e to the minus 3 times 3 to the power 4 over 4 factorial. And this gives me 0.1680 to 4 decimal places. I'm just doing everything 4 decimal places at the moment, but you know in your exam, 3 significant figures is the standard. So that's what we are generally always aiming towards. Now, part 2 is more than 5. So probability when x is greater than 5. Remember, always make this equals. So that's greater than or equal to 6, which means we want 1 minus the probability that x is less than or equal to 5. So 1 minus, and then head into my tables. Just going to block the screen with it here a second. So we've got there where x is less than or equal to 5, so that's going to be 0.9161. And then I can go to the calculator, and 1 minus 0.9161, and that gives me 0.0839. And that's both 4 decimal places and 3 significant figures. Now, don't forget, just while we've got this up, if I just pop this to the side a second, we could have, and I'll switch colour pens, but we could have for part A done, to find the x equals 4, we could have done x is less than or equal to 4 minus the probability that x is less than or equal to 3. And that's these two values here, aren't they? So I'll just circle them nicely so you can see. So 0.6472 minus 0.8153. Sorry about that, I've written it around the wrong way. So it's 0.8153 minus 0.6472. Don't know why I wrote it the wrong way there. And we get 0.1681. So you can see there that to 4 decimal places, there's a slight difference, isn't there? But to 3 significant figures, they will be the same. And that's because these have been all rounded to 4 decimal places. So there is a rounding error that is going to come into play if you keep it all at 4 decimal places, which is why 3 significant figures is the preferred choice in the exams. Now, for part B, you'll notice it's a 2-week period. So that means we have a change, don't we? So let's just call it Y. Poisson now is, or lambda I should say, is 6, isn't it? Because it's a 2-week period. After this, the rest of the questions are pretty much the same. We're looking at Y equals 6. So again, I'm going to use the formula here. So e to the minus 6 times 6 to the power 6 over 6 factorial. All the 6's there. So 0.1606. Now for part B, we have no more than 4. Sorry, B part 2, I should say. Now, no more than 4 means we're looking at y being less than or equal to 4. Because no more than 4 would mean 4 or less. Again, we can look up into our tables for this one, this time with lambda equals 6. From the table, looking at 4, we have 0.2851, and it's that straightforward. Question 2. Here we can see that patients arrive at the hospital department at a rate of 5 per hour. However, when I read A, we can see during any 30-minute period. So that means that lambda is going to be half of this, isn't it? 30 minutes, half an hour, so half of 5. So when I'm doing A, I'll just make that little start here. It's going to be 2.5 for lambda. Okay, it's a rate as we've talked about several times so far, just indicating that you are going to be using your Poisson distribution. Now we're looking at part 1 here, which is just exactly 4. So probability when x equals 4. So there's nothing too difficult about these. Once you get your values out of your calculator, there's nothing, sorry, not out of your calculator, what am I talking about? Once you get the values out of the text, there's nothing difficult about solving these questions, really. It's understanding the question is the most difficult part. So here we've got it just using the formula, and then from my calculator I get 0.1336 there. And that's currently to 4 decimal places. But like I've said before, 3 significant figures is what you really want in the exam. That's what they'll be checking that your answer rounds to. So they'll give the 3 significant figure value, and it'll usually say something along the lines of answers rounding to this. Part 2, at least 3. So at least 3 means greater than or equal to 3. So this is 1 minus the probability that x is greater than or equal, less than or equal to 2. So it's 1 minus, and then we want to go to our tables, because 2.5 for lambda is in our tables. So here you have the table, just squeezing it in, and looking at 2, we get 0.5438. So 1 minus 5438 is 0.4562. Again, that's to 4 decimal places, as obviously the tables are. So if we looked at 3 significant figures, we get 0.456. And that's what we're always aiming to make sure we round to. Now for the next part, we can see a patient arrives at 11 AM. Find the probability that the next patient arrives before 11:15 AM. So this time we're looking at a 15-minute period. So we need to again adjust our value of lambda. Obviously I'm changing letters as we change in our distribution, and a quarter of that 5 is 0.25. To go with the quarter of an hour, the 15-minute difference between 11 and 11:15. Now, finding the probability that the next patient arrives is a tricky one, because what immediately screams to mind is, oh, I must do y equals 1. But that's not really the case, because you're looking at the next patient arriving before 11:15, but there's nothing to say that there couldn't be 2 patients or 3 patients or more. So what you're actually looking at is greater than or equal to 1. Okay, you want at least 1 patient arriving before that. That's what the probability is going to be all about. So this is 1 minus the probability that y equals 0. And this then I would go to my formula. So e to the minus 1.25 times 1.25 to the power 0 over 0 factorial. And that will give me 0.713. And then we've got 4, 9, and so on. So the 3 significant figures, that's 7, 1, 3. But you can quite clearly see here, had I rounded this to 4 decimal places first, then it would give me a slightly different answer here, which is what happens sometimes, why you should be using as accurate an answer as you can. Now with this one, we've got a company has buses that can only be hired for a week at a time. All hiring starts on a Sunday. During the summer, the main number of requests for each Sunday is 5. Okay, so this mean number of requests is a rate, isn't it? And that's what we're looking at. So it is going to be a Poisson distribution. So in this one, we're looking at this mean number of requests here. So here we have that X is distributed Poisson, and it's going to be 5. Now for part A, we're looking at fewer than 4 requests. So we're looking at when X is less than 4, which means that X is less than or equal to 3. We've got a nice value of 5 for lambda, so we can go ahead and look this up in our tables. And as you can see, less than or equal to 3 is 0.2650. So nice and straightforward there, or 0.265 to 3 significant figures. Now, for part B, we can see here the company wants to be at least 99% sure they can fill all requests on a particular Sunday. Okay, so what that means is that we're thinking of n, which is what we're going to start off with. So we want when x is less than or equal to n being the number of buses that we have, at least, or this many buses or less that we always have available, and that is going to be greater than our 99%. So when I think about this, the easiest thing to do is have a look through our tables, isn't it? Because our value of lambda hasn't changed. And we're looking in our tables for 99%. So have a look here in our tables. Here we have 2 values. So if I think of 10, x is less than or equal to 10 is equal to 0.9863, which is less than 99%, isn't it? And probability when x is less than or equal to 11 is equal to 0.9945, which is greater than our 99%. Therefore, the company is going to need 11 buses. Hopefully that makes sense. Yeah, hopefully you're able to follow that. I don't think it was too difficult. It's another one of those questions. As long as you understand what's going on, the questions are easy, aren't they? I guess that's kind of obvious. Anyway, I'm getting off topic there. Fourth and final question. So we've got breakdowns on a particular machine occur at a rate of 1.5 per week. So you can see here, rate. Therefore, we are looking at our Poisson distribution, where lambda is 1.5. I'll highlight the 1.5 as well. Find the probability that no more than 2 breakdowns occur in a randomly chosen week. So part A, we've got X is distributed with Poisson, and it's going to be lambda is 1.5. And there we are looking at no more than 2. So that means that X is less than or equal to 2. 1.5 is going to be in our tables because that's between 0.5 and 10 going up in halves. So here you have it, 2 or less than or equal to 2, 0.8088. And that's part A done. Now part B says the probability of at least 5 breakdowns in a randomly chosen 2-week period. So now we need to adjust our distribution. Over 2 weeks, it's going to be lambda is 3 now. And at least 5 means that we're looking at 5 or more. So greater than or equal to 5. So this is 1 minus the probability that y is less than or equal to 4. And what I need to do here now is just go to my tables. And you can see 4 is here. So we get 1 minus 0.8153. And then from my calculator, I get 0.1847. And there we are with our answer. Of course, you can round these to 3 significant figures, and you should for the exam. I've been a little bit lazy here, so 185 really for that one. That one should really be 0.809 if we go to 3 significant figures here, which of course I am encouraging you to do. The final part of this question, we can see that the maintenance firms agrees to repair breakdowns over a 6-week period, and they're going to give a full refund if there's more than N breakdowns in that 6-week period. Firm wants the probability of having to pay a refund to be 5% or less. This is the kind of question that gives you ideas of where statistics is used or can be used in different real world scenarios. You can take the idea that you've got here and apply it to so many businesses. So, kind of a career in statistics can be quite a lucrative career. If any of you are really interested in this, there's lots of options going forward. Anyway, let's get back on with the question. So they only want to pay 5% or less, pay out when the probability is 5% or less. So first things first, we have a 6-week period. So 6 times 1.5 gives me 9. So that's going to be my value of lambda. So x, y, I don't know what other letter we can use. Not sure what other letter to use. I think I'll just switch back to the x for now. So that's what we've got. X is distributed with Poisson, where lambda is 9. Maybe I should use a different letter. Let's use the letter R for refunds. That sounds nice. And that's it as a sentence there just to explain. It's the number of breakdowns in a randomly chosen 6-week period. Now, N is going to be the least number of breakdowns such that it will be less than or equal to this 5%. And looking at N, we look back in the question, we can see here if there are more than N breakdowns. So we're looking at the probability, I will say my letter R there, too early, where R is greater than N. And that needs to be less than or equal to 0.05. So that's what we've got to work with. So let me just write this down here again. Greater than N, less than or equal to 0.05. Now, what do I always say? Make the inequality an equals. So we got P is R greater than or equals to, no, it's always one more than that, isn't it? And then I want to make this into a less than or equal to. So it's going to be 1 minus the probability where R is less than or equal to N, is less than or equal to 0.05, and then a little bit of rearranging, we get 1 minus 0.05 here. So now we've got the probability where R is less than or equal to N is greater than or equal to 0.95. That is what we're looking at, yeah? So it's all about the setup here. Once you get this first bit right, or from this point, once you get that first bit right, it's straightforward. Now, I know some of you might jump straight from here to here. I always put the equals in first to make sure I don't make any mistakes and I don't end up with one more value. Because, sometimes this could end up being an n-1 that you need and not an n. So I just think, following logical steps each time. Think about what you do with actual numbers when you add 1 to them, when you take away 1 from the value. That will help you do this. Now, we know that lambda is 9, isn't it? Got it here, which means we can now go to our tables. And we want greater than 0.95. So if you look in the tables, either side of 9.5 is here, isn't it? The 13 and the 14. And it's very common practice, even though you kind of work out exactly which one you want straight away, to put the two values down, the ones that are either side of your 0.95. So we've got basically the probability when R is less than or equal to 13, that equals 0.92 0.261, which is obviously smaller than our 0.95. And the probability when R is less than or equal to 14 is equal to 0.9585, which is greater than our 0.95, which then satisfies this, doesn't it? That's what we want. So our value of n is 14. Therefore, smallest, because obviously you could have a bigger value, couldn't you? But smallest value of n is 14. And that's all there is to it. Okay, so, I would say, and I would strongly suggest that what you're always doing with these questions is you write down the two values either side. Okay, all it's doing is just showing the examiner that you go in either side, you know exactly what you're doing, you're looking up in the tables, and then from here you're picking the right value. It does mean that if you do make a mistake along here, you should pick up marks for the correct method later on. Hopefully you found this video useful. Sorry for the little delay in this one, but the next one is coming very, very soon. So if you are waiting for it, hit that bell icon and you'll be notified as soon as it drops.